problem reads, a double pipe heat exchanger for counter-current flow is made up of a 3-inch Schedule 40 steel pipe. Methanol enters through the inner pipe at 80 degrees Celsius and leaves at 55 degrees Celsius. The cooling water enters the annulus of a 5-inch Schedule 40 steel pipe entering at 18 degrees Celsius and leaving at 25 degrees Celsius. Find the length of the pipe given the convective coefficient for methanol is 1825 watt per meter Kelvin and cooling water velocity of 0.5 meters per second. In this problem, it is required to find the length of this double pipe heat exchanger. The length is calculated using the overall heat transfer equation. The overall heat transfer equation would require the overall heat transfer coefficients and the outer and inner film heat transfer coefficients. First, we must find the outside surface temperature of the double pipe heat exchanger. The surface temperature can be calculated through trial and error. First, we must assume the surface temperature to be the average temperature of the cooling water flowing through the annulus, which is calculated to be 21.5 degrees Celsius or 294.5 degrees Kelvin. The parameters of water at this temperature is calculated, such as the specific heat, the density, the thermal conductivity, and the viscosity. These parameters are needed to calculate the film heat transfer coefficients using the Nusselt's equation. The Nusselt's equation would require the Reynolds number, the Prandtl number, and the variables f and k. The Reynolds and Prandtl number can be calculated using the parameters calculated earlier. F and k are calculated using equations from Perry's handbook. F is calculated using this equation and k is calculated using this equation, which involves the Prandtl number at the bulk temperature and the Prandtl number at the surface temperature. Since the surface temperature is assumed to be the average temperature, which is also the bulk temperature, the K would be calculated as 1. With all the variables in the Nusselt's equation calculated, we can now find the film heat transfer coefficient. The calculated HO is shown to be higher than the given HI, which is 1825. With this, we can now check for the assumed value of the surface temperature of the pipe. Here is the heat transfer equation. The TS can be calculated given UI, AI, which can be cancelled from the other side of the equation. The delta T log mean can be calculated using the temperature differences from the temperature ranges listed here. And the surface temperature, the checked surface temperature is found to be 45.2 degrees Celsius. This calculated temperature is found to be greater than the assumed temperature, so we must check this value if it is near the real surface temperature. In order to check the surface temperature again, we must find the parameters of water at this temperature at 45.2 degrees Celsius. And again, the Reynolds and Prandtl number are calculated using the parameters calculated. Now, to find the film heat transfer coefficient, we must use again the Nusselt's equation. But this time, the K will change because the surface temperature is different from the average temperature. Now here, K with the bulk Prandtl number and the surface Prandtl number gives this value of K, 1.06038. The F will be the same, and so now we can calculate for the HO, which is 2937.23 watt per meter squared Kelvin. And with that, the overall heat transfer coefficient can also be calculated, giving 973.068. And now we can once again check for the surface temperature of the pipe using the heat transfer equation. The check value is calculated to be 45.71 degrees Celsius, which is near the earlier value of 45.2 degrees Celsius. Now we can calculate for the length of the double pipe heat exchanger using the heat transfer coefficient with the UI, the overall inner heat transfer coefficient, and the lateral area, which involves the variable of the length and the delta T log mean. W here is the mass flow rate, Cp is the specific heat, and this is the temperature range of the cooling water. With all the variables taken, we can now compute for the length, and it is found to be 6.41 meters.